a signal arrived at a telescope in Russia that nobody expected. September 2016. The Ratan 600 radio telescope in the Caucasus Mountains picks up an anomalous transmission, strong, directional, pointing with surgical precision at a star just 4.24 light-years away. Scientists called it a WOW class signal, the kind of detection that makes grown astronomers go quiet in a room. The star was Proxima Centauri, our closest stellar neighbor, the candidate most frequently discussed as humanity's first destination beyond our own sun. And in that same week, a separate team of researchers was finishing a paper they had been sitting on. Nervously, a paper that would reframe everything we thought we knew about that star. This is the story they almost didn't tell us. To understand what Proxima is doing to its planet, you need to understand what it actually is. Not what it looks like. What it is, in its bones. Proxima Centauri is a red dwarf. Class M, it burns at roughly 3000 Kelvin, barely half the surface temperature of our sun. Dim, small. If you stood next to both stars, it would look like a campfire beside a floodlight, and for a long time that dimness was the selling point. A planet has to orbit closer to a cooler star to receive enough heat for liquid water. Proxima b, the rocky planet confirmed in 2016, sits just 7.5 million kilometers from its star. Earth orbits the Sun at 150 million kilometers. Proxima b is 20 times closer to its star than we are to ours, snug inside what astronomers call the habitable zone. The press called it Earth's twin. NASA called it the most exciting exoplanet discovery of the decade. Headlines announced we had found the next Earth, right next door. But there was something the headlines didn't lead with. Proxima Centauri is magnetically furious. Red dwarfs are fully convective stars. Unlike our Sun, which has a stable, stratified interior, Proxima churns all the way through. Hot plasma boils from core to surface and back again in a constant, violent cycle. This convection generates magnetic fields of extraordinary intensity. Fields that store energy like a coiling spring, until they snap. These are stellar flares. And on Proxima Centauri, they are not rare events. They are the rhythm of the star's daily life. In May 2016, the same year Proxima b was announced, astronomers recorded a flare from Proxima that released 10 times more energy in ultraviolet light than the most powerful flare ever recorded on our Sun. It lasted 11 minutes. During those 11 minutes, ultraviolet radiation striking Proxima b increased by a factor of 68. 68 times the UV dose. In 11 minutes, on a planet sitting 20 times closer to its star than we sit to ours. The numbers don't get better when you do the full math. They get catastrophic. Ultraviolet radiation at those intensities photoionizes atmospheric molecules. It rips electrons free from nitrogen, oxygen, carbon dioxide. The atmosphere doesn't get damaged. It gets sputtered away, molecule by molecule. The stellar wind from each flare acts like a sandblaster on the fragile envelope of gas that any living world depends on. Over 1 billion years of this, you don't have a habitable planet. You have Mars, airless, desiccated, dead. But here is where science did what science always does. It pushed back. A team at NASA's Goddard Space Flight Center ran the numbers on Proxima b's potential magnetic field. And they found a lifeline. If Proxima b had a strong enough planetary magnetosphere comparable to Earth's or Jupiter's, that field could act as an electromagnetic shield, deflecting charged particles from the stellar wind. Not perfectly, but enough. Enough for an atmosphere to survive. Enough for liquid water to persist in pockets. Enough to stay in the conversation. And then there was tidal locking. Proxima b orbits so close and so fast, just 11 Earth days per revolution, that models suggested the star's gravity had long ago frozen the planet's rotation. One face, always toward the star. One face always in permanent night. Early climate models from MIT suggested this might not be fatal. Giant atmospheric wind systems could, in theory, redistribute heat from the blistering day side to the frozen night side. Create a habitable ring of twilight at the terminator zone. A narrow band of survivable temperatures. A world of eternal sunset. It was elegant. It was hopeful. It let people breathe again. Then, 2021 happened. Astronomer Parky Lloyd and a team from Arizona State University published a study analyzing Proxima's flare activity in near ultraviolet, the specific wavelength that destroys the DNA of living organisms and dismantles ozone molecules. In just 9 hours of Hubble observation, they detected multiple UV flares. One of them, scaled to Earth's conditions, would have triggered a mass extinction event. Not a bad UV day. A mass extinction event, in 9 hours of watching. And the magnetosphere argument, a 2021 study in the Astrophysical Journal, found that the sheer pressure of Proxima's stellar wind, even in its quiet periods between flares, is 2,000 times greater than the solar wind Earth receives. A planetary magnetosphere strong enough to resist that pressure would need to be almost physically implausible. The shield was theoretically possible. The environment it had to shield against was functionally relentless. The lifeline held in the models. But the models kept getting harder to believe. Here is the uncomfortable part. The part nobody put in the press releases. The warnings were there. As early as 2007, astronomers Mohanty and Basri had published detailed analysis of M-dwarf flare activity, showing that red dwarf planets in habitable zones would receive UV doses orders of magnitude beyond what Earth life tolerates. In 2013, Segura et al. Modeled what a single large flare does to a tidally locked planet's atmosphere. The results were not encouraging. These papers existed. They were peer-reviewed. They were cited. And when Proxima b was announced in August 2016, almost none of that context made it into the first wave of coverage. The stories were about hope, about proximity, about the romantic idea that our nearest neighbor might harbor life. The flare papers were the footnotes. The existential threat was the asterisk. This is not a conspiracy. It is something more human and therefore more instructive. We wanted Proxima b to be safe. We needed it to be safe. Because if the star right next door is hostile to life, what does that say about the universe at large? What does it say about how rare we might be? Here is where we have to sit with the question, rather than answer it. Proxima Centauri will burn for 4 trillion years. Our sun has perhaps 5 billion years left. By the time our sun exhausts itself, Proxima will barely be middle-aged. It is, by stellar timescale, practically immortal. And in those 4 trillion years, it will flare. Constantly. Violently. The same furious magnetic convection playing out across timescales the human mind cannot hold. Whether something lives beneath that punishment, whether some form of chemistry we haven't imagined yet has learned to endure what we cannot, we genuinely do not know. Life on Earth began in conditions we would call extreme. Hydrothermal vents, acidic pools, radiation-soaked surfaces before an ozone layer existed. Life, it turns out, is stubborn in ways that routinely embarrass the predictions of the scientists who study it. So we are left here, at the edge of what we know, looking at a red star 4.24 light-years away, and holding 2 truths simultaneously. It is probably hostile. And we cannot be certain it is empty. That is not a failure of science. That is science doing exactly what it is supposed to do, replacing comfortable stories with precise, uncomfortable questions. The signal from September 2016 was never confirmed. It was never explained. It simply arrived, strong, directional, anomalous, from the direction of a star we are only beginning to understand. And then, it went quiet. Just like everything else out there. We keep listening anyway, because the alternative, deciding in advance what the universe is and isn't capable of, is the one mistake science cannot afford to make.